Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today we are going to look at one of the application areas of definite integrals. And in our first discussion we have defined the concept of a definite integral as an integral that is has got boundaries between the closed intervals of generally a and b. And I'm going to illustrate this one using the fundamental theorem of calculus that we have mentioned for the integral a b fx dx, which we said is equivalent to f for the upper limit and f for the lower limit for those two specific integrals are given as such. So this is one of the ways that we're going to apply in finding the areas under the curve. And we had said that we can be able to give an arbitrary function for a curve, or rather a definite integral for x, whereby we're going to have y equivalent to the square of x. So this is going to be our curve that we're going to use for this specific illustration. So I'm going to create the limit between that 4 and 0 for the x-axis and for the y-axis. So therefore, one of the application areas is trying to find the area under that is within these boundaries under a curve given as such, that is of course resting along the x-axis for these limits of 0 and 4 for the lower and upper boundaries respectively. So in this case then, therefore, our area is going to be given as the integral from 0 to 4 of our function x squared dx given as such. So this is going to be x cubed over 3 using those square brackets, and 0 to 4 to indicate the lower and the upper limits of integration. So therefore we can be able to represent area given as, so for the upper boundary for fb, then therefore this is going to be 4 to power 3 over 3, and then minus the lower boundary, we're going to have 0 over 3, and then this is going to be given as such. So this is going to be 0 to power 3, which is equivalent to 0. So this is going to give us 64 over 3, which basically is going to be 21 and a third square units. And this is going to represent this area under the curve given as such. So this is one of the application areas of definite integrals. And we're going to see other applications like solids of revolution in some of our videos that we're going to do after this. So I'd like to invite us to kindly go to YouTube and search Ernest Sciences and Mathematics TV channel. Subscribe to our channel and also engage us in the comment section. There are various uploads that I've done on various areas in this concept of calculus for definite and indefinite integrals. So the link that I'm going to put in the description box, of course, is going to be a link of a playlist that we have done and other related areas which are going to assist us complement on this. So catch us in our next video. That is it for now, guys. Bye, God bless you.